is Cambridge Mock 2 MCQs. Theory paper already discussed. So have a look on MCQs. Look at this. Which statement is correct? Voltmeter reading PD electrical circuit is 1 volt. Okay, energy needed. Look, voltage is defined by energy divided by charge. So 1 volt must be 1 joule per coulomb. So the energy needed to move 1 coulomb of charge from Q to P is 1 joule. By definition, it must be positive always. Filament lamp, it always bends towards the voltage axis because resistance increases, right? This is the first quadrant, and first quadrant. Negative axis is this. Now, as the internal resistance of battery increases, how do the terminal potential difference of and the output power changes? Okay, when a battery is connected to a resistor, the battery gradually becomes warm. It causes the internal resistance of the battery stays the unchanged. Okay, look at this formula for terminal PD. Do you know what is terminal PD? If it is the EMF, there is a resistance for the material of the resistor inside, that is called internal resistance, right? Now, if you connect it to a circuit, to a device of resistance R, total EMF is divided into two. One part becomes IR, another part becomes I. Small r is the lost volt and IR is the terminal PD. Actually, this voltage is same as the voltage that is represented at the terminal, right? So terminal PD V is always EMF minus IR. So when internal resistance rate increases, so what happens actually? Internal resistance increases. That means more fraction of voltage according to the ratio of resistance potential divided log V1 by V2 is equals to what? R1 by R2. Look, this main EMF is divided into two parts. One part goes to this internal resistance, another part goes to this. So if internal resistance becomes more fraction of input voltage is dropped inside, right? So automatically, look, I will be reduced, but still IR, that is the lost volt, will be more inside. Okay, because according to the ratio of resistance, R is small, R is more. So more fraction of EMF will be there. So definitely the product IR, that means lost volt, increases. So terminal PD decreases. Now, what happens to the output power? Output power is actually VI, but we cannot do any comment on I because I will be changing too. So I can change it to V square by R. Actually, this is the output PD. That means the PD given to capital R, right? So if terminal PD decreases, definitely output power decreases. So A is the correct answer, right? Okay, now come to the next. A cell is connected to a resistor. This the current when the resistor is second in parallel. Current becomes this. The EMF and the resistance cell is this. Okay. Look, this is actually capital R. Now, 1 I is equals to what? EMF by R plus R, right? You don't know EMF, no issue, but you know I. So EMF is equals to what? IR plus I. That means 1 into R plus R. So EMF is basically 1 into 3 plus. And on the other hand, when second identical resistor is connected, look, in parallel, if you connect another identical resistor in parallel, total resistance to the output becomes R by 2, right? So in second case, this becomes half of this 3, that means 1.93 into 1.5 plus. Look, the EMF is same, so if you equate them, this becomes 3 plus R is equals to 1.93 into 1.5 plus R. If you solve it, you'll get R first, then put into any equation, you get EMF, right? This is the way. I'm not solving this. You can do it by yourself. Understood? Okay. Now come to the next part. A battery has negligible internal resistance. Okay. When the statement is there is no resistance inside, then EMF is constant and all the EMF is given to the output, right? If it is 12 volt, all will be go to the output. We don't know what is the voltage. Read the question first. At 3 resistors of the same value, the current is 0.3. What is the current in resistance? Good. Look, you can, in this case, this is better. Choose any value by your choice. If you think that 10 ohm each, so actually what is happening, X as 10, and in the lower pathway, resistance is what? 10 plus 10, what? 20. In parallel connection, the main current is divided. But you know, voltage is same for parallel connection. So smaller resistance pathway is the easy pathway. So current is more there. Since the resistance in the lower pathway is double, current will be half. Or current in the lower pathway, its double is to the X. Clear? Okay. So if you think that current in this pathway is I by 2 will be in the lower pathway. And I plus I by 2 will be 0.3. That means 3 by 2I is equals to what? 0.3. Right? So it becomes what? 0.2, I think. Hope you understood. Now next one. What is the range of output voltage? This is very simple. Actually, in this case, we use a trick. If it is 12 volt, it is 1/4 of PD or EMF. In this case, for simplicity, we make one side 0 volt, another side what? 12 volt. That means this side is 0 volt and this is what? 12 volt. This is not PD, it is P only, potential. It is what? Potential. Now this 12 volt is divided equally, right? Because resistance values are same. Voltage is divided according to the ratio of resistance, you know. So what will be the voltage dropped across each will be same. The PD, we show it by this arrow, double-headed arrow. It is actually 6 volt. It is also 6 volt. This is PD. But if you are asked to mark a P potential at the midpoint, it will be 6 volt too. Why? Because the PD has to be 6 minus 0, 6, and 12 minus 0, it is 6 volt. Now, the tuner is connected to the lower resistor only. So when you push the tuner down, the voltage to the output drops to 0 volt. And when it pushed to the topmost, you cannot go to the another resistor because tuner has been fixed up within the resistor. It's not possible to switch the tuner sliding contact from one resistor to another, right? So When it is to the lowermost point, it is 0 to the output. When it is at the topmost point, output is 6 volt. So 0 to 6 volt is the range. Hope you understood. Which component has the greatest resistance when the potential difference across it is V1? Look, never think that resistance is the gradient. No, never. Or inverse of gradient. You may think that okay, current is in the y-axis, or it is the resist gradient, inverse of gradient. No, resistance is not delta V by delta I. No, it is not defined this way. Resistance is the ratio V by I. That means if a graph of current voltage is like this, in any case, if it becomes flat, look, this line has a zero gradient, but still there is a resistance V by I. V has a value, I has a value, so there will be resistance. So resistance is not delta V by delta I. Resistance is actually the ratio V by I. Look at this. At all these four cases, voltage value same, right? R equals to what? V by I. Voltage value same. Lowest current for what? Resistor D. Okay, device D. So component D. Therefore, R equals to what? V by I. Voltage same for all. Current is lowest for D. Resistance will be highest. Done? Done. Now, a cylindrical wire has a cross-section area A, number of density N, the wire. Okay. Drip velocity, formula is I by NAE or NAQ. Q is the charge of electron. It has a fixed value. Right, EA has a fixed value 1.6 times 10 to the minus 19 coulomb. A second was the same cross section, but the area is 0.5 of previous 2N. What is the current in the second wire? Okay, look, for first one, I is equals to NAEV. Now, for second case, if it is I2, will be what? NAEV. So if you solve, it will be what? 0.5 and 2 will be cancelled. So 2 NAEV. Therefore, it is I. So 2I. This is. Now come to the next. Which description of Kirchhoff's law is correct? It considers a current at a junction and the consequence of the conservation of charge. You know this, I think. Which statement about the combined resistance of the two resistors is correct? It is greater than, no, it is less than. For any parallel connection, total resistance must be less than any single value. বুঝো নাই? আবার বলি দেখো, if it is 20 ohm, if you connect a 2 ohm cell in parallel, total value must be less than 2. No way. Total value must be less than 2. You may check. 1 by 2 plus 1 by 20 power. Check. It must be less than 2. The diagram shows four identical resistors connected in a circuit. The resistor dissipate the most power. Which resistor dissipate the more power? In this case, best idea is no value added means choose any value by your choice. Assume that every resistor is 10 ohm. Now assign a value. Okay, check the total resistance of them, 20 and 10. So 10 plus 1 by 20, 10 plus 1 by RT means R total. Sorry. 10 plus 1 by 20 plus 1 by 10 power minus 1. So get a value, then power. Okay. Then for power, get I square R for each. Okay. Or another way you can solve it. Mm, You know, power is VI, but power has another popular expression I square R. Check. Current is highest at which point? Definitely current at this point is highest because this current has been splitting into two. Okay. So current is highest in A, so highest power will be there. Got it? Because this current will be divided at this point. Right? That's it. Hello. Bye bye.